lecture will explain how to do the second version of the rule of arrow in, or conditional introduction. So this is version 2. Okay, so how version 2 works is a little strange when you first see it. So suppose we have some formula Q. And suppose that we want the formula P arrow Q. Well, no problem. If we have Q, then we can derive P arrow Q by arrow introduction. In fact, we can derive any conditional we like that has Q as a consequence. So we could also derive Y arrow Q by arrow introduction. We could derive A and B arrow Q by arrow introduction, and so on. And if you think about it, if you think about the truth table for the conditional, this won't seem quite as strange. So recall that whenever the consequent of a conditional is true, then the conditional as a whole is true. So if you have the formula P arrow Q, if P is true and Q is true, then it's true. And if P is false and Q is true, then it's also true. So that's what makes this rule valid. It's a little weird, but it's valid. And it's super useful in cases where, so I'm going to talk through and let's look at this. Okay. So if we didn't have this rule that just let us derive any conditional we like from the consequent, here's what we'd have to do. So suppose we have the premise Q, and what we want to derive is P arrow Q. If we don't have this rule here, then what we have to do is assume P in hopes of getting Q. And then we can get it by arrow in. Okay, so we have a Q, but we need to get a Q inside the box. Okay, so we can do this really weird and artificial thing. We can make P arrow Q using that. So 1, 2. So that's and introduction on lines 2 and 1. And then we can take the Q out of P and Q, but and elimination on line 3. And then we can derive P arrow Q by arrow in on line 4. But that's just silly stuff. It's completely artificial, as you see. We just artificially moved the Q into the box where we needed it. So we don't need to go through all that nonsense. Instead, what we can do on line 2, we can just derive P arrow Q by arrow introduction on line 1. As in the previous version of the rule of arrow introduction, we cite when we're doing the justification for the arrow in step, we cite the line that contains the consequent. This is the same in both versions of the rule. In both cases, we cite the line that contains the consequent. The difference is whether we had to make an assumption or not. And so obviously, if we don't have to make an assumption, if we can just go straight to the punchline, so to speak, and say, aha, P arrow Q, then that's very handy. So let's see how this works in a proof. So suppose we have the formula, I don't know, let's say P arrow Q, and suppose we have the formula R, and suppose we're trying to get the formula P arrow R. So it might be tempting to think, oh, we have to assume P because that will be useful for line 1. But it doesn't actually help us because getting Q doesn't help us. We don't need it. We can just go right to P arrow R by arrow introduction on line 2 because we already have the R. And breaking apart line 1 doesn't help us get it in this somewhat artificial proof I've performed, seen. But you will find it comes in handy sometimes. And I will show you in the proof lab how you can work with this rule.